So hello everyone, in this video I'm going to talk you through how you can analyze our own data, which is very exciting. As you know, I love data analysis. So here we go. So this is SPSS for those of you who have not seen it before. It looks a bit similar to Excel, but it is specific for data analysis. You can do lots more things with it. So here you can see the first column, that's all your codes that you've given your participants, and then all the other columns that were on the Excel sheet are here at the top. So their age, was it their national team that they were supporting or not, and how happy were you, or how happy would you be if your team would win, how sad would you be if they would lose, etc. And these are all the other factors. So how effective were you at the end of the match? If they won, to what extent do you think that's down to good luck or not? To what extent do you think it's competence that caused the outcome, etc. Now the first thing that we need to do is to create one variable for social identity. Because at the beginning we asked them these questions, so how happy would you be, how sad would you be, how much does it matter, how much do you feel it's part of you, how superior do you think your team is. Now those questions are all essentially asking how strong is your social identity. So we think that all those questions essentially measure the same thing. Now this statistical procedure you can use to test if that's actually the case, and that's called Cronbach's alpha. What you're doing is essentially a reliability test. So does one variable measure the same thing as another variable? It doesn't say, as Alexander pointed out, it doesn't actually say anything about the validity on it. It doesn't tell you does it actually measure social identity or not. It just measures whether all of those variables are tapping into the same thing, whatever that thing may be. But let me just show you, and then it'll make a bit more sense. So what you do is you go to Analyze and then Scale, and then you choose Reliability Analysis. And the ones you want are happy, sad, matter, part of you, and superior, and you stick them in there. And then you need to click on Statistics, because that's where you indicate what you want the program to do. Now what you want is scale if item deleted and inter-item correlations. And then you click Continue and OK. This is where it gets exciting. Well, sad people like me get excited. This is the overall reliability that you get. It's Cronbach's alpha value. It's 0.729. And Cronbach's alpha, it ranges from 0 to 1. And the higher, the better. If you have a really high Cronbach's alpha, that means that all of your variables are measuring the same thing. They're very correlated with one another. So if you know one, you can know what the other will be. Anything above 0.6 is considered okay. So 0.72 is very good indeed. So we can be sure that, or not sure, well, not ever 100% sure, but reasonably confident that all of our variables are measuring the same thing. What do you want? Go away. Now this is interesting because you can see Cronbach's alpha, what Cronbach's alpha would be if you deleted that particular questionnaire item. So if you were to delete the question, how happy would you be if your team won? You can see that Cronbach's alpha would actually become smaller. Only if you took away the question about how superior do you think your team is, only then it would be a bit higher than what we've got at the moment. But none of the others you could actually remove. So that's a really good sign, which means we can actually add up all of those scores. So we can create one variable, and I've done that here, call it social identity. So that's the sum of these 5 here. So these values are all quite large. So now what we want to know is, does the strength of your social identity, so how much you identify with that team that you're supporting, does that relate in any way to how people explain the outcome of the match? And I say relate to deliberately because we're going to look at correlations, and correlations don't say anything about what causes something. I mean, it could be that the strength of your social identity causes you to think it's all, about, if they lose, it's all about bad luck. But it could also be that it's the other way around. It actually, when your team wins, that strengthens your social identity. So we don't know what direction it's going to go. Maybe there's something else that causes both. So all we can say is that they're probably related. So we're going to do a correlation analysis. So we go back to analyze, and then correlate, and then bivariate. And we want to put in, of course, social identity, and we want to put in how much affected they were, whether they think it's good luck, competence, bad luck, or incompetence. We stick all of those in, and it will correlate everything with one another. Now here you can choose which correlation you want the program to do. Now, in first year we talked about the different measurement scales, whether you had nominal, ordinal, interval, or ratio data, and that determines what kind of correlation coefficient you can do. So you can only use Pearson if you've got a ratio or an interval scale. So if your numbers are real numbers, and if the interval between each point is the same. We don't have that here. They're just more or less of something. Somebody who says I'm affected 0.9 on the scale, it doesn't mean, well, let's have an even number. If you say 8, I'm affected number 8, so quite affected, it doesn't mean you're twice as affected as somebody who puts a 4. It doesn't work like that. You can say they're more affected or less affected, but not necessarily twice as much. That's not meaningful. We can't use Pearson. We've got to use a non-parametric correlation instead, and that is Spearman. Leave everything as it is, and then we hit the OK button. Oh no, we don't hit the OK button. Excuse me, we don't hit the OK button. Not just yet. There's something else we need to do. Bear with me. So just cancel that. We will come back to that. Before we do so, we need to split the data set. And I forgot this when we met last week as well. I don't learn, do I? We need to split the data set. So we want to look separately at the games that resulted in a win and the games that resulted in a loss, because we want to separate what happens with the correlations in each group. To do that, you go to data, and all the way to the bottom select cases. So first we want to look at the losses. So you click if condition is satisfied, and then if if win-lose equals 0. And I have indicated that when I put all the data in, I've set number 0 to mean losses, 1 was a draw, and 2 was a win. So if you put it like this, if win-lose equals 0, continue. Don't delete the unselected cases, just filter out. Then we can keep the other ones for later. Keep it like this, and then click OK. Then what you can see when you look at the data, is that all the ones that ended in a win or in a draw have got a strike through. So only the ones that are still in their normal shape will be used in the analysis. So now we can go back to correlations. Hopefully it will have, no, it has not remembered. It has not remembered. It's a bit like me, it doesn't remember. So we'll go to put all these back in. Not Pearson, Spearman, leave everything else. Now we hit OK, the moment has come. So, what we can see a lot. For some of you, this may be the first time you see a big correlation table like this. Don't worry, it looks way more complicated than it is. So you know correlations, they range from -1 to +1, and the bigger in absolute terms, the better. And in this case, SPSS has made it easier for you, and all the correlations that are statistically significant have got little asterisks above them. If it has 1 asterisk, it means that it's a correlation that has a 0.05 chance of being just a random occurrence. If it's got 2 asterisks alongside it, it means that it has a 0.01 chance of being just a random event. So here you can see that that's a smaller than that. So a correlation of that size is very unlikely to happen just on the basis of chance. The important one to look at is so the row of correlations with social identity. And as you can also see, it's completely a duplicate. This part, this triangle, is the same as at the top. So you only need to look at one triangle, then you get all of your correlations in there. So as you can see, there's a positive correlation between the social identity strength and how much people were affected. So positive, that means as the strength of social identity goes up, so does the extent to which people are affected. So these two correlations are not significant, but go away. But this one is. So there's a positive correlation between people's strength of social identity and their tendency to attribute a loss to bad luck. That's exactly what we predicted. There is, I was going to say no correlation, but that's of course not true. There's no evidence of a correlation between social identity and incompetence. So this pattern, so there is evidence that they attribute it to bad luck, but no evidence that they attribute it to incompetence. That pattern is exactly what we would predict. And now we need to do the same thing, but then for the wins. So we need to go back to select cases, and then instead of win-lose 0, we put in win-lose 2. And then we do the same thing, because it will have, just go back to our data, where are our data? It will have now omitted the losers and the draws. Losses. The losses and the draws from the analysis. So now we will be looking only at the wins. So it will have remembered this time. It's still there. We can just leave it as it is. You don't need to change that, because it will just simply apply the same analysis to the new selected part of the data. So you click OK again, and then you get, that is the new one. And again, you only need to look at the top one, really. So the strength of people's social identity, can you go away? Yeah. The strength of people's social identity is related to their tendency to be affected by it. It's a positive correlation, so the more they are affected, the stronger their social identity. Now, in the previous table, we saw there was a link with ascribing things to bad luck. Obviously, you wouldn't expect them to attribute a win to bad luck, but you could think maybe they attribute it to good luck instead. But there's no evidence that they do so. Instead, they attribute it to competence. So luck is something that's outside of your control. So when something bad happens, that's the best thing to do. So it's just bad luck. Then it's not about your competence. But when something good happens, as here, you win, the stronger the social identity, the more likely it is that they actually attribute that to competence. So things, internal, stable competencies. That's exactly what social identity would predict, and it's very beautiful, I think. Of course, we want to put this into a graph, ideally, because it's nice. Graphs are nice. It shows actually what we found in a more easily accessible form. So the way to do that, you go to Graphs, Chart Builder. Okay. Now what you need to make sure of is that all your variables have got that little yellow thing that's called scale symbol to it. Then you can actually plot things nicely, and you can change that when you go back to the other screen here. If you go to variable view, you can change scale, you can change it to ordinal or nominal. So I know they are ordinal, but if you leave them like that, you can't create a graph. We can actually stay here. We can just go here. The kinds of graph that you want is a scatter plot, and what you do is you click and drag it into this area, and then what we want, so we are currently we have selected only the win data, so that's good. Social identity we want to put on the x-axis, and it was competence that it correlated with, so we take competence and we stick that on the y-axis, and then we hit OK, see what happens, and we get a graph, which is beautiful, very beautiful. Of course, it's nice to show the correlation line, so we're going to do that as well. So you double click on it, which opens it, and then you want to put a line in, so that's elements, under elements, fit line at total, and you get a correlation line. Now, if you want to put this in a report, which you will have to, if you're going into level 2, you will have to create these, because you'll be doing correlation research. You need to remove this, and you just remove it by clicking on it once so it becomes yellow, and then deleting it. I'm saying that and now it doesn't do it. Will you please just do that? No. So don't listen to what I say. Let's see. Should be able to remove it. Attach label to line. So under reference line, you don't want, because that's essentially the formula for that line. So D-click or tick, apply, close. It still has it. Ooh, would you mind going away? It doesn't want to go away. It doesn't want to go away. Yeah, that drives me nuts. It really does. And it doesn't want to do. Yes! It's gone. It's gone. And you want to remove that as well. So here you have it. So that's a moderately sized correlation, even though it doesn't look much, but we have a good sample of participants, so it's showing us significance, which is great. And you can do the same thing for the lose condition. So the first thing you need to do then is to go back to that program, go back to data, select cases, but then select win lose equals 0, and then go through the whole process of doing the graph again. There are lots of other things you can do with this graph. You can sort of change the size of the numbers, you can sort of remove the grey bit from the middle. Let me just show you that, because that's quite important. If you right click, properties window, fill, you can make that white and then apply. That's how you need to put it in a report if you do. So these were our beautiful data. The one other thing that I promised to tell you about was the Festival of Social Science. That's on the 8th of November, it's a Tuesday. In the evening I will be presenting this research and talk about social identity and football in general at Pitori Stadium. Yes, Pitori Stadium. So it's between 7 and 8:30. I will be in touch with you near the time to tell you exactly when and where it will be, but I really hope that you can come along to that. That should be really great. The one other thing I need from you is a passport photograph. Well, not a passport, but a photograph of just your face, because I'm going to do something with that in the talk. No pressure. Well, I hope this was helpful, and if there are any questions about the data analysis, please let me know. And thank you all very much for getting these data, because without you it wouldn't have worked. Okay, so I'll see you later, if not during term time.